This is lesson 2 of chapter 6 and section 6.2 in your textbook. We're doing slopes of parallel and perpendicular lines today. Let's just talk about these words first if you don't know what they are. When you have parallel lines, it's like train tracks. So parallel lines look like this. They never intersect each other. They are going in the same direction, but they are two separate lines. It's actually even in the name with the two L's. That's how you can kind of remember it. So those are parallel lines. Let's take a second before you read anything. What do you think is true about the slopes of those lines? Our intuition is correct here. Yes, the slopes are the same. So parallel lines here have the same slope. We can see that in the box. Okay, the rise and the run will be identical. They have the same steepness. Okay. And the word perpendicular. Perpendicular lines are lines that have a 90-degree angle between them. So they're almost like opposite to parallel. They do intersect and they have kind of opposite slopes in a way. So let's look at the example here to figure that out. So when you have perpendicular lines, so you have this 90-degree angle between them, the slopes are negative reciprocals. Let's unpack what that means. So here, let's just look at our quick example. We have a negative slope. And this one is like a little bit more shallow, and this one's kind of like a steep positive slope. Right? So one of the slopes is going to be negative, one's going to be positive. So that's what they mean by negative. Okay, the signs are flipped. And reciprocal means the rise and the run are also flipped. So if we have a look here at our two lines, this one has a rise of -3 and a run of 5. So it's going to be a negative slope. Whereas this one has a rise of 5 and a run of +3. So it's like they're flipped. So the slope of the blue line would be -3 over 5. And the slope of the red line, rise over runs, would be 5 over 3. Notice how they are flipped. So we call those in math reciprocals when you flip the positions of the numbers. And they are also opposite signs. Okay, so those are the two main things to remember in this lesson. Parallel lines have the same slope and perpendicular lines have negative reciprocal slopes. Okay, let's have a look at some examples. Here's the first one. Are these lines parallel? So sometimes lines look like they could be parallel, but we're not 100% sure. We can figure out if they're exactly parallel or not by determining the slope. So let's do that. The lines are labeled, so let's use the same labeling, J, K. So let's count. 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6, 7, 8. So the rise over run would be -4 over 8. We can reduce it to -1/2. Let's do the slope of GH. So if I get -1/2 as well, I know they are parallel. Let's see. 1, 2, 3. 1, 2, 3, 4, 5, 6. Rise over run. -3 over 6. Upon first inspection, it doesn't actually look like they're the same, -4 over 8 versus -3 over 6, but if we reduce it, we do see that these are the same slope. And so, in fact, they are parallel. Okay, so if you are asked in like on a quiz or an assignment or something, are these lines parallel? You should be saying yes or no, but you also need to justify your answer. And by justifying your answer, you need to prove it essentially. So like a good way to prove it here would be to determine the slope of each line and then say because they have the same slope, they are parallel. So everything I've written here is required for a question like this. Okay, let's look at a little bit of a trickier question, a spicy one. This says, is this a rectangle? Okay, just before we answer that question, let's just review what a rectangle even is. A rectangle has four sides, but a rectangle does not look like this. So this shape has four sides, but this is not a rectangle. But this shape is a rectangle. Okay. Oops, I'm just realizing now you can't see that entire shape. That shape there is a rectangle. So what's the difference? This one is a rectangle. So a rectangle is when you have four sides, but also to be a rectangle, you have to have 90-degree corners. Essentially, the sides have to be perpendicular to one another. Okay, so to figure out if this is a rectangle or not, we're going to have to figure out if we have 90-degree angles in each corner. So I'm going to put a question mark. Okay, how are we going to figure that out? Well, let's see. We're going to use the slope. So I'm going to start by finding the slope of AB. We can see we have to count down 1, 2, 3, 4, 5 over 1, 2. We can't reduce that. So I'm just going to color that so we can see. Okay, now let's do the slope of a adjacent line, BC. So let's count. The rise would be 1, 2, 3. The run would be 1, 2, 3, 4, 5, 6, 7. Let's see if we can reduce that. No, we cannot. Okay, let's have a look at those. Let's investigate them. So if there's a 90-degree angle between those two, 90 degrees, if there's a 90-degree corner, then those two lines would be reciprocal, or would be perpendicular. But we know they're not here. These are not, slopes are not negative reciprocals. They're opposite signs for sure, but the numbers are totally different. Negative reciprocals. So the lines are not parallel. Sides are not perpendicular. And so this is not a rectangle. This would give you full credit for this answer. So you do need to, if I ask you if this is a rectangle or not, you do need to calculate the slopes. You need to identify that they either are or are not, in this case, negative reciprocals. So the sides are or are not perpendicular, and so this is not a rectangle. Okay, that's the end of the lesson.